Good morning, good afternoon, and good evening wherever you are. We hope you are staying safe.
If you have not done so yet, please subscribe and ring the bell to be kept up to date on news and the latest tutorials. In our last video, we promised that we would go over delegates, events, exceptions handling, and reflection. As we produced the video, it would have been very long, so we have broken it out into two parts. This is the first part. It's all about delegates and events.
We'll start with delegates as it's the plumbing for events, but they can be used on their own. So what are delegates? In the real world, you want to go shopping, but you don't have time or you don't want to go to the grocery store. So you would delegate that work to a company like Instacart, who will do the shopping for you and deliver your groceries at your door. In .NET, delegates perform a similar function, and they are a reference type. Delegates allow us to encapsulate methods. What we mean by this is that delegates are pointers to one or more methods. Just as we had variables referencing classes and structs or passing them as parameters, we can do the same with delegates. Think of it this way. The variables we have created so far were data structures, and delegates are executable code that gets passed around and performs an action. Why do we have delegates? Delegates allow us to pass messages between classes. As we stated, delegates are executable code, and as we pass it around, we can introduce change without modifying our code. This feature makes an application extensible. Let's create and work with delegates and see them in action, then work on real-world examples. To create a delegate is simple. We need to define a signature as we did with methods, but not a body. Just like a method, it can have an access modifier, and so far we know of public and private. Next, we use the keyword delegate, then a return type if we want a value to be passed back, then a name for our delegate. We can also pass delegates as parameters. That's pretty much it for creating a delegate, but this is not useful. So let's create a method and see how we can use the delegate to call our method. There is nothing fancy about this. We just want to show you how to create and use delegates. We will create two very simple methods. One that adds two numbers and another that multiplies and then returns the sum result. After that, we need to assign our method to our delegate. Now, we can invoke our delegates, which will call our method. Notice that our delegate matches the signature of our method by maintaining parameters of the method, the return type, and the pointer in the method. A delegate must have a similar signature to methods it's pointing. In this example, we use a delegate as you would call a method. Let's create another method and then pass our delegate so it can be used as a callback. Earlier, we stated that the method does not have to match precisely. There are two variances with delegates, covariance and contravariance. Contravariance allows a method to have a return type that is more derived than the defined in the delegate. The following example is straight from the .NET documentation, but provides a great example of covariance. We have two classes, a mammal class and a dog class that inherits from a mammal. We have two methods, one that returns a mammal class and another returns dog class. If we create a delegate that only returns a mammal, we can then use it to point to both methods. The method that returns dog is the covariance because of our delegate has a mammal return type, but the method returns dog, which is inherited from a mammal. Contravariance allows a method that has parameter types that are less derived than those in the delegate type. So the example for contravariance is the same with the return except for parameters. We have been using delegates pointing to one method, and this is called a single cast. When we put multiple methods to one delegate, it's called multicast. We can do this by using the plus operator or use the combined method. Let's see this in action. We will use the plus operator to combine the delegates for this example. And notice that when we call the multicast delegate, we do get both methods executed, but we return the last invocation. Notice that the return result only returns the last delegate. The rest were discarded. If we need to act on the return results, then we would need to get a list of delegates, then execute them one at a time to get the results. So we went right into how to use delegates, but let's peel the onion. the keyword delegate is actually system.delegate class. But then how does it multicast? Here's what really happens when you create a delegate and compile the code. .NET does something special. It creates a class from our delegate. And look at the code, we don't see that. The IL code, and understand that it is a delegate, so it shows what our source code would look like. If we chose to view it as an IL code, then we can see that we do indeed have the delegate as a class, and it inherits from another class called Multicast Delegate. Multicast Delegate then inherits from the delegate. So delegate has two important properties, method and target. It also has method get invocation list. We have already seen the get invocation list where it will get the list of all delegates. We also use the method property to get the name of the delegate. The method property is using reflection to give more details on the method, like name, parameters, return type, and many more. We will go over how to use this when we discuss reflection. The target property gets the class instance. If the method pointing was static, then this is null. So last item to remember, if we have a multicast delegate and there are 3 delegates being invoked, if the second one throws an exception, no other delegate will execute, and the exception is thrown to the caller. When we discuss exception handling, we go over how to handle or purposely throw an exception. We are now ready to see a real-world example. We are going to create a chat service where clients can connect to a chat server and send messages. Since we haven't learned how to do networking with C#, we will stub out the networking implementation. We are cheating there, as both the clients and the server are all hosted in one process. In the real world, the clients would be different systems connecting to the central server. What we are hoping to convey here is that the intercommunication between classes using delegates. Let's understand the problem we are trying to solve. We want a chat server that will listen for incoming messages and broadcast them as all its clients. The chat server can also send messages from an administrator. The clients will register with the chat server and send messages. When one client sends a message, all other clients should receive it. When a client connects to the chat server, we will keep a list so that when we start chatting, we can send messages to connected clients. When a client disconnects, we are going to remove that client from the list. We will use Multicast delegates for this. Let's create a public delegate for the chat server. This delegate does not return a value but accepts the string message. Clients will use this delegate to send messages. Next, we will create a private field that will hold all our multicast delegates so that our chat server can use. Our chat server needs to have a connection and disconnect method. As clients connect, they are added to the multicast delegate, and when they leave and disconnect, we remove them from the multicast delegate. The chat server will need a method to send messages. When a connected client sends a message, we need to send that message to all clients. Now we are ready to implement the chat clients. The chat client will have a name to identify the chat user. The constructor of the client will accept the username and the chat server. And when we connect to the chat server, we register our client method that the server can use to send messages. We will also create another method to send messages to the server. So let's test the scenario by creating a few clients and send messages from the server and the client. So it looks like everything is working. We will post this code to our repository. You're probably wondering, couldn't we just use interfaces to extend our application instead of delegates? That is one way to make your application extensible. But before giving our advice on which to use, let's see how this works. We'll create a simple interface that represents a unit of work. It has a contract of two methods, start and end work. Next, we create two classes, a manager and an employee. As the employee completes their task, the manager is notified. Now let's take a look at the sample, but with delegates. Instead of interfaces, we will use a delegate. Remove the interface from the manager class and then update the employee class to have two fields. They can be properties that will take our delegate, and for this example, let's stick to fields. We now assign the manager method so that it can call back on work status. Both scenarios do the same, but let's say now we need HR also to listen when the work started and ended so that they can do payroll. In the delegate scenario, you wouldn't change anything. You would just simply create a new class that had the same signature as the work was status delegate, and now we have the HR class listen on when work started and ended. For the interface route, it will require a bit more work. So we hope that example clarifies the fixability of delegates. Okay, when do you choose interfaces versus delegates? Choose a delegate when an eventing design pattern is used, if calling code does not need to access other properties, methods, or interfaces on the object implementing the method. An easy composition is desired. When we talk about object-oriented design, you will hear favor composition versus inheritance. A class may need more than one implementation of the method. Choose an interface when a class only needs one implementation of a method. The class using the interface will want to cast that interface to other interfaces or class types. The method being implemented is linked to the type or identity of the class. So for example, comparison methods. So hopefully this gave you a good idea of what delegates are and why we have them. And Microsoft also has a good example of delegates. We will post the link for you.
The reason we went over delegates was that it's the plumbing for events. Imagine using a phone and calling a friend. The phone system has the architecture to use the phone number and route your request and ring your friend's phone. Your friend checks the caller ID and he sees that you are calling him. Then your friend accepts the call. When you dialed your friend's phone number, you raised an event. Next, your phone delegated that request to your telephone provider. Then your telephone provider rang your friend's phone, sending the caller ID information. Your friend noticing the caller ID and accepts the call. and the event was handled. There are a few pieces to events: raising an event, delegating the event, handling the event, passing event arguments. Let's see an example of this in a GUI application. GUI stands for Graphical User Interface when you use Microsoft Word, which is a GUI application. You can type some words and sentences, then select a button to force spell check. You can also do other functions like select text and make it bold. By choosing to spell check, you raise an event, the same by making the text bold. Word delegated that event to the spell check engine, which passed your text and completed the spell check and displayed the correct words, and the event was handled. We are going to use Windows Forms to display an example of the event, but we are not going to discuss how it developed Windows Forms. We will have tutorials on Windows Forms later on. Events are an essential part of the GUI application. Generally, events are used in GUI applications but are not limited to that. Let's review how a Windows application would use events. In this scenario, we will use a Windows Forms application and add a button to it. The button control and other controls have events. For example, button control has a click event. When we click, it will raise a click event. Right now, we are not handling it so that it will do nothing. If we register the event, then we can handle the event and show a message box that the button was clicked. Now let's take a look at how this is implemented. If we go to the form, then select the button, then view its properties, you will notice that we have a lightning bolt icon. These are all the events that our button supports. Here you can see that the click even is mapped to button 1 click method. When we double clicked on our form, the Visual Studio generated all the plumbing for us. If we open the form, we can see that underneath we have a designer class. If we open that, we can see that we have the button 1 variable that is our button on the form. Then the click event is mapped using an event handler. This is our delegate and is pointed to our button 1 click method. If we go to our button 1 click method, we can see that we have 2 parameters, an object and an event args. This is because the delegate event handler has a signature with the same parameters. Event args allows us to pass arguments to our method. For completeness, the object is the button itself, so we can cast it as a button and use it to get additional properties. The event args is the mouse click, like position, or which mouse button was used. In our Windows form, there is a built-in delegate event handler, which was used in our previous example. Let's create our own custom events. We will rewrite our chat server so that we are using events instead of delegates. To create an event, we use the event keyword. Then we update the code to use the event instead of a delegate. What was done here is wrap the delegate in the event. Now you are wondering, there is no difference between the delegate and the event, but there is. In our previous tutorial, we inherited from a dictionary object so we could have a class that could get a value either by name or index value. We extended the dictionary class. The event does the same thing, it adds and extends the delegate. So let's take a look at the differences. We can assign values to the delegate properties and override values that existed. So here's an example. Notice that we have no safety. As the delegates get passed around, it could be nulled out and we lose all the methods. Also, note that the delegate doesn't have to be in a class. As we mentioned earlier, it can reside outside the class. So let's try the same with events. We have to create a class for events as events are associated with a class. Notice that we can't do the same with events. Now you think, what if we assign a new value? So same as for, this is not allowed. You can go one step further and say, well, let's skip all that and go straight to the delegate, and we null it out. Again, you can't do that. So what happened here is that the event wrapped the delegate and adds safety around how we register with the event. When should you decide to use a delegate versus an event? If you want to pass around executable code or have a callback scenario, then use delegates. And if you want to use a notification system where the class can initiate an event and you want to be notified, then you can use events. Which brings us to our next point. How does a class raise an event? In the Windows Form scenario, the framework wired all that, and at runtime, the framework monitored the mouse, and as the mouse was pressed down on the button, the framework called the onClick method to raise the event. So let's use a simple class to show how a class can raise events. When events are needed to be called generally, there is a method associated with the event and also has a prefix of on. For example, if our event test class, we can create on print console and then call the delegate. But somewhere in the class, some work needs to happen and then call the onPrint console so that all invocations can be notified. Let's use the built-in event handler just like our Windows forms. We are going to create a new event argument and inherit from Eventargs. This is so we can pass our message. Next, we update the delegate to use event handler as well as our print to console method. Now, the code works, except how do we pass our message? The default handler has an event arg that has nothing for us to use. In this case, we can use the generic event handler. So let's update our code to use the generic handler. First, we will create a class and inherit from the event args. Next, we just update our code to use the new event args. before we leave this topic, we wanted to let you know that there are action and func delegates, and we will go over them when we discuss lambdas. We hope that we were able to show you how to work with delegates and events. Now that we've learned about delegates and events, let's bring it to a close by extending one of our existing applications. We are going to hook into existing events and extend our Tic Tac Toe application. What we like to do is save the game state if the console window is closed, and when the game launches, we need to ask the user if they would like to continue with the previous or new game. Let's break down the problem. When a game is closed and it still has moves left, we save the game board for future use. When a game is played, we need to check to see if we have saved the game. If so, then we need to ask the user if they like to discard or continue with the previous game. For this, we need to hook into the application domain events. An application domain, app domain, is an isolated environment where applications execute. In .NET Core, where we have written all of our C# code, there is one application domain created. We are not going to go too deep into this topic just yet, but we will use the app domains event to listen when the application is closed and save our game board to a file. So let's hook into the event. When the application closes, the event is raised and our method is called. Here, we will get the game board and save it. How do you save the game board? Our game board is a two-dimensional array, and we could walk the array and save it as text. Then on reloading, we could recreate it by reading the text file and create the array. This is one solution, but .NET allows us to serialize objects. This means that we take the object and create a stream of bytes and store it anywhere in memory, database, or file. The reverse of this process is deserialized. Now on startup, we want to check to see if we have a saved game and load it by deserializing. We check for the existing of the file, and if the file exists, then we load it. We are not going to remember which player's turn it is. We will leave that as a challenge for you. You could create your own structure and serialize it. We are going to save it as a file. We are going to create the file and have access using a stream for our write operations. And next, we create a binary formatter. And this object will take our array and serialize it. We can serialize objects into JSON, XML, binary, and other formats. So thank you again for your support, and we hope you're staying safe, and we look forward to seeing you in our next tutorial.